Hello, learners. Hoping that you're doing well. I want us to start our lesson. That is our maths lesson. On Monday, you were taken through by Mr. Deuri. I hope that you were able to learn some new concepts that maybe you didn't have. And I also understand that you cannot unmute yourself. Oh, if you can unmute yourself, please, you can share with me how or whatever you did in your previous lesson so that we know where we can start from. Cedric Nyaga. Cedric Nyaga, are you saying something? Cedric, are you able to unmute yourself?
Yeah.
Yes, yes.
What did you learn last time?
We are through differentiation.
Yes.
The teacher gave us, we were going through differentiation.
Oh, you're going through differentiation?
Yes.
And I remember, so how far did you go on this topic of differentiation?
Applications.
Stationary points.
You discussed up to stationary points.
Yes.
So you can get the, and I believe the teacher also mentioned that it can also be called the turning points. And
Yes, yes.
can also, or can be told maximum or minimum points. Okay. So did you discuss about how to test maximum or minimum points?
Yes.
Oh,
Yes.
Robinson is saying no. Robinson, were you in class?
yeah, I think
Yes, Robinson.
Paliminification, notes nilifikisha too when we're doing stationary points, how to find the points, not the testing part.
Or how to find the turning points or stationary points, eh? Amuku test minimum or maximum points.
Oh yeah, that we did.
Oh, mlifanya hiyo.
Uh-huh.
Any other question? Maybe I think it's like you cover the whole concept. Were you given any assignment? Cedric, let me get back to you. Were you given any assignment?
I don't know because my phone switched off before we finished the lesson.
Robinson, did you finish the class?
No, internet cut out.
Zuel? Zuel, can you hear me?
Yes, sir.
Did you finish the class on Monday? Maths lesson?
No.
Okay, who went up to the end of the class? Was there any assignment? Please share with us so that one where we can start from. You just unmute and then you share with us. Who went up to the end of the class, or how did the class end? Let me get. May I ask Austin Jura? Austin? Francis Mulwa,
Yes.
did you end the class? Did you go up to the end of the class on Monday?
Yes. Yes.
Was there any assignment given?
No, it was just the one that you gave us earlier on.
Or the questions that I gave
Said you'll
earlier
give
on?
it. You'll give. Yeah.
The one I gave
The
was
one for KF.
they were first 10 questions, or were they 5 or 10?
They were. No, they were 10, number 28 to 36.
28
To 37.
to 37, eh?
Sir, 37. Yes.
Okay. Did you revise all the questions?
No, we did not revise with him.
Oh, so
Yeah.
where do you think we can start from?
People can say the.
Okay, but what I can say, maybe if the question were not revised, so since that you went through other concepts with the teacher of the turning points and how to test whether it is maximum or minimum, why can't we check the work that we did and then you tell me where there's a problem from the last 10 questions that we did in KMF? Maybe you can go through them, go through your work and tell me where kuna shida. The work that I gave last time. That's from number, it was from number 37 to 28, the last 10 questions. Any challenge from those numbers, the one that I gave? Did you try the questions? Were you defeated somewhere? Any challenging area? Because we said this is a topic that we must get the topic right away because it is heavily set in KCSE. If you check at the KMF, it is heavily set at the KCSE. So I'm asking, was there any problem or any concept that you didn't get or any question that you missed from KMF, the topic of differentiation and its applications, number 28, number 37? You can raise up your hand, I'll give you a chance. You can raise up your hand, I'll give you a chance so that we are together. Yes, Mulwa.
Number 29C.
Number 29C.
C.
Find the equation of the normal to the curve at x is equals to 1. Is that the question, Mulwa?
Yes.
So does it mean that you didn't discuss equation of the tangent and equation of the normal with the teacher?
We did.
Mulwa?
I couldn't do it.
Or you couldn't do it?
Yes.
Okay, I can do the whole question because okay, let me do the C because B is asking about the stationary points of the curve and I think this is Kosawa. Let me go directly to C. But before I go to C, there's also equation of the tangent to the curve. Now we are told that the equation of the curve is given by y is equals to x cubed minus 4x squared minus 3x. So for us to get the gradient of this, we differentiate dy over dx. This is 3x squared minus 8x. Mashara David, I'll send away from my class. Can you mute? David Mashara, mute. Thank you. So dy over dx is 3x squared minus 8x minus 3. That is our gradient. We are told to find the equation of the normal to the curve at x. At x is equals to 1. X is equals to 1. Now, when x is equals to 1, what will be your gradient? Remember, in terms of x, your gradient is 3x squared minus 8x minus 3. At x is equals to 1, what is your gradient? Substitute x is equal to 1 into your dy over dx. So we say 1 squared minus 8 times 1 minus 3. I hope, Mulwa, you are following. So your gradient will be 3 minus 8 minus 3. So your gradient here is negative 8. That is your gradient. Now, equation of the tangent that I've just mentioned and equation of the normal, they are perpendicular. Just note that one. Equation of the tangent is perpendicular to equation of the normal, to the gradient of the normal. Ensure that that one is captured. The tangent and the normal to the curve, they are perpendicular. Now, the gradient that you get, the first gradient that you get is the gradient of the tangent. Please also note that it is the gradient of the tangent. So the gradient of our tangent is negative 8. So we must get the gradient of the normal for us to get the equation of the normal to the curve. So m1 times m2 is negative 1. m1 times m2 is negative 1. Therefore, if m1 is negative 8, then m2 will be 1 over 8. Something like that. m1 negative 8, m2 will be 1 over 8. So we are told to find the equation at x is equals to 1. Since you don't have a point, you don't have a coordinate point or a point, you will find for a point if x is equals to 1, what is y? So that you can get a coordinate xy where there is normal to the curve, the line which is normal to the curve is passing through. So we go to the equation of the curve. Y is equal to x cubed minus 4x squared minus 3x. And our x is 1. So if our x is 1, substitute to the equation of y, this will be 1 cubed minus 4 times 1 squared minus 3 times 1. So this will just be 1 minus 4 minus 3. This is 1 minus 7 is negative 6. So the point is 1, negative 6. That is where the equation of the normal to the curve is passing through, and the gradient we have gotten as 1 over 8. Therefore, what is the equation of the normal to the curve? 1, negative 6. And then we have x, y. So y plus 6, that is change in y over change in x, x minus 1. This should give us 1 over 8. So cross multiply 8 into y plus 6, 1 into x minus 1. So 8y plus 48 is equal to x minus 1. So 8y is equals to x minus 1 minus 48. So x minus 49. Therefore, y is equals to 1 over 8x minus 49 over 8. And it's good to leave your answer as 1 over 8x minus 6. 6, which brings 48, and 1 over 8. Don't leave your answer as an improper fraction. Mulwa, are you there?
Yes, I'm okay.
You are okay?
Yes.
Have you followed what I've done?
Yes.
Good. Any other question concerning the, do you know how to get the equation of the tangent to the curve? Yes.
Yes.
Okay. Any other question from number 28 to number 37? You can raise up your hand and then I'll give you a chance to ask your question or to interact with other class members. I'm still waiting for the question. Michael Mushiri, do you have something to say? Yes, Michael Mushiri. I can't hear you. Okay. If there's no other question, because I can't see any hand up. If there's no other question, Zuelu, kuna swali?
Hapana, teacher.
Umeelewa vizuri from number 28 to number 37?
Nimeelewa.
Okay. Maybe a number different from what we have discussed, because the questions are many here. We have also number 1 to number 27, which I know we can't do right now. But any other concept which is related to differentiation, you can ask, because at the end of the lesson, I want us to go and try handle number 1 to number 27, so that we can get all the concepts. The good thing with KCSE is that every question has always something new with it. There's always something new with every question in KCSE. They are never the same. Can be from the same topic, but there's always something new, something that the examiner wants you to get that is not in other questions. So it's good to go to other questions also. And try them out. Maybe you have tried 1 to number 27, and maybe a question challenged you. Just maybe before I give you the assignment of the the question, so that we can finish this topic of differentiation. Nataka tumalize hii concept so that we can go to integration and its applications. So in case you have a challenge, just if you have your KMF there with you, can you go through number 1 to number 27, those that we have not done, and see if there's a question that you cannot answer as we speak, so that as I give you the assignment, I'm quite sure that you are going to handle all the questions comfortably. Let me give you a minute. If you have your KMF with you, I believe most of us have their KMF. Kindly go through and tell me which concept in differentiation you have not understood. And I'm going to explain to you right now before I hand over the assignment to you. Something like that. And I will encourage us to be putting on our photos, because I don't see the reason why you are seeing me and I can't see you. Please, let's have I don't know, what are you hiding? Hmm? You are just a man and therefore you should not hide your face. Ama nini mna ama you are too dark, we can't see you, but that's you. There's no problem. Wacha watu waonane. Unajua, like I told you, you will be holding meetings, and nowadays meetings are through Zoom. You've never seen President Uhuru Kenyatta meeting other presidents na yeye amejificha. You cannot see that. Let's have some kind of good habits. Unajua, you have never seen a president having meetings na yeye amejificha.
Acha.
Jainjiri,
Can we go to
tafadhali.
number 14?
Jainjiri, you have a question?
Yes. No,
Do you have
teacher.
a question?
No.
And why are you making noise?
I was talking to someone.
Why can't you mute ukiongea na mtu? Okay. Kama hakuna swali, I can go ahead and explain integration and its applications.
Can you go through number 14 as an example?
Number 14 as an example. On which area?
On maximum speed attained.
Differentiation or integration?
It's differentiation, number 14.
Differentiation. Okay. Robinson has requested we go through number 14 as an example. So number 14 says the displacement s meters of a particle moving along a straight line after t seconds is given by. I hope, Robinson, that is the question. Just confirm to me.
Yes.
Good. Plus 3/2t squared minus 2t cubed. And I want to charge all of us to be together. Let us also write the question. For those who don't have the KMF, I know not all of us work on a KMF. The question says S is equals to 3t plus 3/2t squared minus 2t cubed. Displacement s meters of a particle moving along a straight line after t seconds is given. Something like that. Question A says, find its Netanyu na kutoa kwa class, uende pia kelele yako huko nje. I'm removing you with immediate effect. Thank you for being with us, but you are misbehaving. I'm really keen on our character, my friend. So if you just misbehave kidogo hivi, you get out of my class automatically, immediately, without even a warning. We want to be serious. This is Mangu High School, therefore we must have a serious class. Si ati unakuja hapa unafunga mdomo kama crocodile in water. I'm going to remove you with immediate effect. Just like that person anajiita Netanyu. Sijui Netanyahu, sijui what. Let me continue. We are told in question A, find its initial acceleration. Find its initial acceleration. Now, initial acceleration is when velocity is what? Tawas Mugambi. When we are told initial acceleration, what does it mean? Yes, Tawas. I can't hear you, Tawas. No, something's wrong with the mic. I can see you are talking, but I can't hear you. Samuel Gakinya. Samuel. Gakinya.
Yes.
When we talk about initial acceleration, what does it mean?
Acceleration before it starts moving.
I know that, but mathematically, what does it mean? That's from English lesson. What is zero?
T is 0.
T is zero. So can we differentiate until we reach that acceleration? So ds, we are differentiating s with respect to t over dt. We are going to get 3.
Excuse me, Chair.
Yes.
Could you please repeat the equation?
Oh, yeah.
Could you please
Okay.
repeat the equation?
The question says the displacement s meters of a particle moving along a set line. The displacement s meters of a particle moving along a straight line after t seconds is given by s is equals to s is the s meters. S is equals to 3t plus 3 over 2t squared minus 2t cubed. Gitonga, do you have the question?
Yes, thank you.
Good. So in question A, we are told to find its initial acceleration. Find its initial acceleration. So we differentiate to get our velocity. So that's we're getting 3t plus, you're getting 3 plus 3t minus minus 6t squared. So velocity is equal to 3 plus 3t minus 6t squared, like that. So therefore, acceleration is dv over dt. This will give us again 3 minus 12t. 3 minus 12t, and we are told that t is equal to 0. T is equal to 0. Please, Ken Kahindi, can you mute your mic? Ken Kahindi, mute. Good. So when t is equal to 0, acceleration tumepata ni 3 minus 12t. So t is 0. That means A will be 3 minus 12. So you're getting negative 9 meters per square second. Now, negative 9. Tawas, are you following?
Yes, I can hear.
Eh?
Yes.
And Robinson also asked the same question. Number 14, that we try to do that number 14 as our example. So we are getting acceleration as 3 minus 12t. 3 minus 12t. That's our acceleration. And I think it's correct that way. We are told to find its initial acceleration. 3 minus 12t. I don't know whether Robinson tumekujibu vizuri.
Yeah.
Calculate the time when the particle was momentarily at rest. So when we are told that a particle is momentarily at rest, we said that it is not moving. Therefore, velocity is equal to 0. When a particle is momentarily at rest, then v is equal to 0. If we check at our differentiation, our v was 3 plus 3t, 3 plus 3t minus 6t squared. So this one is equal to 0. If you rewrite this in quadratic equation, as quadratic equation, it will become 6t squared minus 3t minus 3 is equal to 0. Let me try the factor method. Product is negative 18 and sum is negative 3. So we have negative 6 and positive 3. We have negative 6 and positive. If you multiply the two, you get negative 18, and if you add, you get negative 3. So I have 6t squared minus 6t plus 3t minus 3 is equal to 0. And I believe all of us know how to work out quadratic equation. So 6t, I get t squared, I get t alone, sorry, t alone minus 1 plus 3t minus 1 is equal to 0. So I have 6t plus 3, and then I have t minus 1 is equal to 0. So I'm going to get 6t plus 3 is equal to 0. So 6t is equal to negative 3 divided by 6 by 6. So t is equal to negative a half. Or I have t minus 1 is equal to 0. T is equal to 1. Something like that. But in exam situation, now that you are a candidate, you must remove this t is equal to negative a half from your choices. So because you know that time cannot be negative, you say ignore t is equal to negative a half. Therefore, your t will be 1. So the time when the particle was momentarily at rest will be when t is equals to 1 second. When t is equals to 1 second. Kwa hivyo, when t is equal to 1 second, that's when it was momentarily at rest. Then Roman 2 says, its displacement by the time it comes to rest momentarily. So displacement when it comes to rest, displacement is s, and we want to get s when t is equals to 1. So our s was 3t plus 3 over 2t squared minus 2t cubed. So our t is 1, therefore s will be 3 times 1 plus 1.5 times 1 squared minus 2 times 1 cubed, just the same. So this will be 4.5 minus 2. 4.5 minus 2, we get 2.5 meters. We get 2.5 meters or 2.5 meters. The maximum speed attained, speed attained, it is when acceleration is equal to 0. You attain the maximum speed when you cannot accelerate further. When you can't accelerate any further, then you attain your maximum speed. So let's go to our acceleration. Our acceleration was given as 3 minus 12t, 3 minus 12t, and this will be 0 because you cannot accelerate, you cannot attain any further speed. That's the maximum speed you can attain when you can no longer accelerate. So therefore, acceleration is going to be 0. So we say 3 is equals to 12t divided by 12 by 12. So t is when t is a quarter. T is going to be a quarter. That's when we are going to attain our maximum speed. So when t is a quarter, what is our speed? We go to velocity. Velocity was 3 plus 3t minus 6t squared. 3 plus 3t minus 6t squared. Substitute a quarter. 3 plus 3 times a quarter minus 6 a quarter squared. So this will be 3 plus 3 over 4 minus 6 times 1 over 16. This one is 3 over 8. If you use a calculator, you're going to get 3 and 3 over 4 minus 3 over 8. 3 over 4 minus 3 over 8. You'll get 3 over 8. So our answer is 3 and 3 over 8 meters per second. That was the maximum speed attained, like that. Robinson, are you there?
Yeah.
Have you followed how you have done the question?
Yes.
Any other area in that question that you need me to maybe explain again?
Sasa niko sawa.
Uko sawa.
Yeah.
Robinson, can you take me through how I can do number 18?
A stone is thrown vertically upward from a point 0. After t seconds, the stone is s meters from 0. Given that s is 29.4t minus 4.9t squared, find the maximum height reached by the stone. Vertical acceleration. Chacha nijaribu kwanza.
Okay, well, before you try,
Yeah.
because you cannot try if you don't have the idea. What is the idea here?
Vertical, it's funny vertical acceleration.
Hii kajiwe murusha juu, si ndio?
Displacement itakuwa chat tunasema displacement it will go 2 times.
Displacement?
The displacement will be like the distance will be twice juu itafika max height alafu irudi chini.
Displacement will be twice. Yes, Robinson?
Saying displacement will like twice. It will be twice because the maximum height that it will reach will have to be the distance is traveled upward and downward divided by half, divided into 2.
Ukienda hivyo utakwama. Ukienda hivyo you will get your 0 easily. Okay, if you throw a stone, the idea here is very simple. That's why I'm really insisting that we must attempt all the questions, because unapata kila swali iko na different idea that the examiner wants you to know, or examiner assumes that hiyo concept hujaijua. So when you throw a stone upwards, it reaches a point where velocity is equal to 0. Robinson, before hiyo swali yanze, before hiyo jiwe, or before that stone starts to come down, it will reach a point where velocity it is 0. That stone will stop upwards kwanza ndio yanze kurudi chini. That should be the concept there that must be understood by the one doing the question. Because if you throw this stone up, it will go up and then the maximum height it will reach up, ikiwa huko juu, it is when it will stop and start coming down. So you cannot add the displacement like twice and then divide by 2. No. Actually, you need to know that the maximum height attained by this stone will be when velocity is equals to 0. When velocity will be 0, because the stone will be momentarily at rest uko juu kwanza ndo yanze kirudi chini. So when it will be momentarily at rest uko juu, ikifika the highest height itaanza kurudi chini. That's something that must be understood. So hiyo concept kama hiyo huwezi ipata kwa maswali mengine. It's not there. It is in very few questions. What about if tomorrow you get it for 10 marks? So that's why I'm insisting to all the students here. Please, can you go through number 1 to number 27? And in case of anything, please ask. Take this time to get your A. Take this time to get your A. Don't waste time. Imagine Mungu amekupatia another 1 year, whole year actually, to get your A. Yes, Samuel? Can see your hand is up.
Teacher, I'm asking whether you could go through number 15.
Number
About the
15.
turning points.
Number 15.
Yes.
Okay. So Robinson, number 18. Before I got number 15 for Samuel. Robinson, number 18.
Number 18.
Have you seen it now?
Maximum height.
So what are we going to do first?
We're going to differentiate it first so that we get the equation for velocity.
Then you do. Then you equate that one to
0.
to 0. Then you get the value of t. Cynthia?
Yeah.
Then after getting t, where do you go?
Then after we've gotten the value of t, we go back to the equation of displacement. Then we substitute for the values.
Very good. Very, very good, Robinson. That's the way to go. Okay. Samuel has requested us to do number 15 for the turning points of the curve. Find the turning points. So here, Samuel, we are not determining the nature of the turning points. If you're told to determine the nature of the turning points, then in that case, you must test the maximum and the minimum. Like number 26. 26, you can see there's that B Roman 1 says, determine the stationary points of the curve. Yeah. So this word, determine the stationary points of the curve, is the same as determine the turning points of the curve. Turning points and stationary points are the same. Then B Roman 2 of number 26 says, for each point in B Roman 1, determine whether it's a maximum or minimum. So that Roman 2 is called determining the nature of the point, determining the nature of the turning points. Number 15 is a bit easy because we are not told to determine the nature of the turning points. We haven't been told to determine whether we determine the maximum or the minimum. Remember to find the turning points. So it's a bit easy. Now, the turning points, we said, is just dy over dx. You get the gradient. And at any turning point, we said at any turning point, gradient must be equal to 0. Any turning point, any maximum point or minimum point, gradient must be equal to 0. Please note that. So our equation is y is equals to 6 plus 2x minus 4x squared. Therefore, dy over dx will be equal to 2 minus 8x, 2 minus 8x. And 2 minus 8x should be equal to 0. 2 minus 8x will be equal to 0. And therefore, 2 is equals to 8x divided by 8 by 8. So our x is 1 over 4. Our x is a quarter. So the turning point is at when x is a quarter. So we are told the point, and I have always insisted, when you talk about the point, we mean the coordinate. When you talk about the point, we mean the coordinate. So therefore, the coordinates, when x is 1 over 4, what is the value of y? We go, tunasema hivi, we go to the equation of y. Our y was 6 plus 2x. X yetu ni a quarter. Minus 4 into 1 over 4 squared. So y will be equal to 6 plus a half minus 4 times 1 over 16 minus a quarter. So a half minus a quarter, it is a quarter. Therefore, our y will be 6 and 1 over 4. Therefore, our point xy will be equal to a quarter and 6 and a quarter. That is where we have the turning point. Find the coordinates of the turning points of the curve whose equation is this. Number 15, you get your 3 marks. Someone, have you followed?
Yes.
Have you understood?
Yes.
Good. Ni wapi ilikuwa inakupatia shida, Samuel?
Sikuwa naelewa how to get the gradient.
Or how to get the gradient?
Yes.
Sasa hiyo umeelewa vizuri. Good. Another question before I move on to integration, because it was also suggested it was an area that we needed to cover. But remember, you have the assignments of number 1 to number 27, because I know you're going to meet again on Monday. So you have a whole weekend to try yourself. And I've said, let me tell you this, other schools are really working hard. Our competitors, wachana zile shule ziko karibu na fence yenu hapo. Hizo shule ziko karibu na fence yenu wachana nao. Schools that we compete with are really working hard. They are working hard. Therefore, it's unless sisi pia to work hard, we are going to be beaten in exam. Please, can we work and work very, very hard? Let's work very hard. Yes, Vincent Muli?
Sure, my question is on trigonometry 2.
Trigonometry 2, yes.
Number 2, I don't know how to do it.
So, do you want us to leave trigonometry, to leave integration for now? We go to trigonometry 2?
Only that one question.
Only that one question. It's on page?
Page 90.
Page 90. Trigonometry 2. Page 90, which KMF are you using?
Mine was 2017 one.
Okay, I get it. Trigonometry 2, we have said number 2?
Yes.
2 sides of a triangular plot of land. That one? Is that the question?
Yes.
2 sides of triangular plot of land are 52 and 28 centimeters. Given that the angle between these 2 sides is an obtuse, the angle is obtuse, and that the area of the plot is 576. Area is 576. Find the perimeter of the plot. Now, here we know that the area is a half AB sine theta, of which theta is the included angle between 28 and 52. So 576 is equals to a half times 28 times 52 sine theta. So we have 14, that is, if you simplify a half and 28 to get 14, so 576 is equals to 14 times 52 times sine theta. So can we divide 14 times 52 both sides? 14 times 52 both sides. So we have 576 divided by 14. And again, we divide by 52. 0.7912 is equal to sine theta. So what is theta? Sine inverse of the answer. Sine inverse of the answer. I'm getting 52.30 degrees. But remember, you have been told that this angle is obtuse and our angle is acute. So find the perimeter of the plot. That means that the angle will be, Muli, if you remember the unit circle, where we have the 4 quadrants, we said the first quadrant is theta. Second quadrant is 180 minus theta. Third quadrant is 180 plus theta. And the fourth quadrant is 360 minus theta. I hope Muli unakumbuka kitu kama hii. Let me just show you.
Yes, I remember.
Good. So kama ni obtuse angle, tunaenda in which quadrant, Muli?
The 180 minus theta.
So 180 minus 52.30. What do we get?
127.7.
So our angle is 127.7. So you are not going to use 52 at all. You should not use 52. You're going to use 127.7. That is the angle, 127.7. Then we know the area. So you can give your length ingine ya triangle, you can give it x. So like we have 28, we have 52, and then we have x. Those are three lengths of the. Now, since we know the area will remain the same, area will remain the same. We are told to find the perimeter of the plot. For us to get the perimeter of the plot, lazima tutafute ex. Ex ni measurement gani? Na tayari tushapata angle in between. So can we say that area is equals to which can we use sine rule or cosine rule? Something that can help us. We can use a cosine rule here. Muli, are we together?
Yes.
Unajua cosine rule?
Yes.
Good. Juu nimeona sine rule hatuwezi tukatumia. Juu tuko tu na angle moja. But I can see we can use sine rule. We can use cosine rule, sorry. Cosine rule tutaanza na x, hii length. Na ujue hii angle yake ni 127.7, not 52.3. So you're going to use x squared. If you know cosine rule, you can move on together. X squared is equals to 28 squared plus 52 squared minus 2 times 28 times 52. Then cos angle x, which is 127.7. So we have x squared is equals to 28 squared plus 52 squared. Tunapata 3488 minus 2 times 28 times 52 times cos 127.7. We are getting negative 1780. That's what I'm getting. So negative 1780. So negative and negative, they are going to cancel out and become a plus. Just confirm that. Yes. So our x squared is equals to 3488. 3488 plus 1780. We are getting 5268. Na naona hapo kama ungetumia 52 ungepata hiyo minus ungepata positive. Cos of the angle ingekuwa positive. That's why they were able to state that the angle is obtuse. So if you find x squared or square root x, we are getting 72.58 centimeters. So we have 72.58 centimeters. So therefore perimeter is 28 plus 52 plus 72.58. Perimeter is equals to, if you add that, Muli ume-add?
Yes.
What are we getting?
152.58.
Answer wanasema aje?
$152.59.
152.59 or 0.58.
0.59.
0.59. Hiyo tume lose wapi hiyo one decimal place?
It in terms of 72.586, it was 72.586. So to four standard figures, it's four significant figures.
I get it. For them, they worked with 4 significant figures. Good. I get it. But the main thing is to understand your concept. Huwezi nyimwa marks. Shida ni ile round off to 3 significant figures, lakini ukiweka values zako to 4 decimal places or whatever, na wajasema, you cannot be denied marks. So that's what we were supposed to do. The angle was to be obtuse, and therefore if you use 52.30, huwezi pata your answer hivyo. So you are getting minus, you add, you get 5268, we square root, and then you get the perimeter. It's a very good question. You can see only 2 sentences na marks ni 8 marks. Only 2 sentences na marks ni 8 marks. Muli, thank you for bringing me to this topic. Hii topic ni topic ingine candidate afai kukosa. Kiangalia setting of this paper, of this topic trigonometry 2. Imekuwa kikuja throughout. So ni vizuri, if you want to get an A, lazima kuwe na formula ya kupata A in maths. Si ati unaamka tu alafu unaingia kwa mtihani unafanya hesabu unapata A. Hana, lazima angalie zile frequently set questions or frequently set topics, and then you measure on them. Like 2019, it was 10 marks. 2018 also 10 marks. 2017 was also 10 marks. 2014, 2015, they were all 10 marks. Zote. So ni vizuri wewe, like Muli has done, he has been revising this topic. And that's why amekuwa na swali ya kuuliza. And I believe wale ambao hawana swali ya kuuliza, they are also going to revise other topics and then ask questions. Remember, here we are doing revision. So your question is of great help, not only to you, also other students. Good. Muli, you have any question?
No.
I can't see any hands being raised up. So I can go back to integration. Unless someone has a question. You can ask a question from a different topic. Si lazima ati integration. Because after integration, not all of us had asked. It was only a few that said we do calculus. One of the areas for calculus, also statistics. But now we have done differentiation and its applications. Please ensure and promise yourself that any question on differentiation, whether ikuje aje for now, promise yourself that now you can get questions from the topic.
Yeah.
Yes, Abdi Majid?
Yeah, just a suggestion. I don't know, after we are done with integration, start doing division. Dimensional geometry.
Your volume is low. Just come up again.
Like I am just suggesting, after we finish revising this subtopic integration, I don't know if you can do questions on 3-dimensional geometry.
3-dimension, 3D?
Yeah.
That is okay. And Abdulmajid, you can arm yourself with some few questions, maybe 2 or 3, or even 1, so that at least it can exactly where your need is, so that it can tell us where to go. Sawa, Abdulmajid? Good. I can see even we are all remaining with 8 minutes to the end of the lesson. So maybe you can just do one question on integration, and then we move on. Unless someone has a question to ask. So at Abdulmajid, you will remind me of 3D after we are through with integration, eh?
Fine.
Good. Integration. Okay, we have the topic of integration as integration, but we also have integration and its applications. First, I will go to integration. The way it is as a topic. Integration, the way it is as a topic. And I'll have a question, says this, that came in 1994, although we also have one that came in 2018 and also 2016. Let me go to the one that was set in 2016 because it is carrying at least some good marks. It is 10 marks question. 2016 KMF. If you have it, we can go through together. The gradient function of a curve is given by the expression. So our gradient function, remember gradient function is dy over dx, don't forget. So dy over dx is equals to 2x plus 1. That is the gradient function of the curve. If the curve passes through point -4, 6, the curve passes through point -4, 6, find the equation of the curve. Equation of the curve, we integrate the gradient. Please note down that one. Equation of the curve, we integrate the gradient. So y is equals to, when we are integrating the gradient, we have 2x plus 1. So ex equals raised to power 1. So can we add 1 there? So it becomes x raised to power 2, and then you divide 2x squared by that 2. I believe you know how to integrate, but in case just you have forgotten, I can still remind you. So we are going to get y is equals to x squared plus x plus c. C is a constant. X squared plus x plus c. C is a constant. And remember the curve is passing through. Yes, Kelvin? You have a question?
Okay. I'm lost. Which number are we discussing?
I've said number 12. Number 12, the topic of, unajua kuna integration, alafu kuna integration and its applications. Uko wapi wewe?
Oh, inasema the displacement x meters of a particle t seconds is given here.
Hapana. Kuna topic, kuna 44.4.
Yeah.
Na kuna 45. Na kuna 45.2. Hii point 1 ndio tulikuwa tunafanya.
So, okay.
44.4 ndo tuko.
44?
44.4. Topic number 44.4.
Number 12.
Number 12, yes.
Okay. Inasema the gradient function of a curve is given by the expression 2x plus 1.
Good, good. That's where we are.
Okay, thank you.
Tumesema tutakuja kwa applications baadaye. Wacha kwanza tupitie gradient integration kama topic.
So,
Then we shall come to its application later on. That is 45, topic 45.2.
Thank you.
Good. So we have differentiated this gradient function. Tumesema for us to get the equation of the curve, we differentiate gradient function. So we integrate. So we have integrated 2x plus 1, na tukapata x squared plus x plus c. How do we get the c? We have been given the points where the curve is passing through. The curve is passing at x -4 and y is 6. So can we substitute x -4 and y is equal to 6 to part a c? So we go and say 6 is equals to -4 squared plus negative 4 plus c. So 6 is equals to 16 minus 4 plus c. So 6 is equals to 16 minus 4 is 12 plus c. So 6 minus 12, we get negative 6 is equals to c. So what is our equation now? Y is equals to x squared plus x minus 6. That is our equation of the curve. That is the equation of the curve. If you check at it, you will see that we are correct. Number 12, y is equal to x squared plus x minus 6. Sorry. Then we have the values of x at which the curve cuts the x-axis. The values of x at which the curve cuts the x-axis. You know, when a curve cuts x-axis, that is y is equal to 0. At x-intercept, y is always equal to 0. So 0 is equals to x squared plus x minus 6. Weka y, penye kuna y, weka 0. Penye kuna y, weke 0. That means the quadratic equation where product is equal to negative 6 and sum is positive 1. We can say 3 negative 2. Yes. So x squared plus 3x minus 2x minus 6 is equal to 0. So we have x here, x plus 3, and then we have minus 2x plus 3 is equal to 0. X minus 2, x plus 3 is equal to 0. So the points here is x is equal to 2 or x is negative 3. The values of x at which, so hatujaambiwa point, kama ni points tungetafuta values of y. Lakini hapa tumeambiwa tu values of x at which the curve cuts the x-axis. Up to that point you score your 6 marks. Hadi hapo unapata 6 marks. Determine the area enclosed by the curve and the x-axis. So integral of that. But again, it is good to plot. Ni vizuri sana kuplot. Ni vizuri uplot ndio ujue hii area inakaa aje. Because it may not be above the x-axis all the time or below the x-axis all the time. It can go up na kuja chini. Sasa therefore hapo lazima utaintegrate tofauti. So I urge you to plot, you sketch this curve when x is 2 and when x is negative 3. Uone inakujaje. Hii curve, it will cut your y-axis at y is negative 6. Tangalia vizuri, when x is 0, y will be negative 6. At negative 6 ndio hiyo curve ita, it will cut your y-axis. So that means hii curve yetu iko chini. Hii curve yetu iko chini. Hii curve yetu iko chini. Therefore, the area is going to be negative. That's what, because we only cut your y-axis once, where y is negative 6. So you can say 2 negative 3, integral of 2 and then negative 3, and then you bring this equation, x squared plus x minus 6. Then if you integrate this, you're going to get x cubed over 3 minus x squared, or plus x squared over 2 plus minus 6x plus c, like that. So if you put x is 2, you are going to get, substitute x ni 2, utapata 8 over 3 plus 4 over 2 minus 12. Na hii ingine kama x negative 3 utapata negative 27 over 3 plus 9 over 2 plus 18, something like that, plus 18. So, and we are subtracting. So I have 8 over 3. 8 over 3 minus 12. I'm getting negative 9 and a third minus, this is negative 9. So negative 9 plus 4.5 plus 18. So negative 9 and a third minus negative 9 and a third minus negative 9 and a third minus 13 minus 13.5 minus 13.5. I'm getting negative 22.833 recurring as a fraction. Negative 22.833 recurring. Let me check what they have, whether they put their answer as a fraction or as a decimal. That's number 12. They're getting 20.8333 recurring, but as a decimal, as a fraction, 20.20 and 5 or 6. For us, we are getting, maybe I've not added well somewhere or subtracted well somewhere. But that's what we should expect. So maybe in our next lesson, we are going to talk more of integration and how we can get the area. And we are going also to repeat the question that I've just done, number 12, especially Roman 3. Hatujamalizia vizuri. You can see we are even beyond time, but we are going to do that. Your assignment is to go through differentiation so that you give it a clean sheet. Differentiation, give it a clean sheet, and then maybe on Monday we are going to revise differentiation, some few questions of that has some challenges, and then we go directly to 44.4, topic 44.4, that is integration. Tupitie vizuri, uwe uko sawa. Any question before I end the class? Nathan? Yes?
So you're going to repeat the question after in the next lesson?
Alan Mukua, sauti kidogo.
I was asking, utarudia hiyo Roman 3 in the next lesson?
Nitarudia Roman 3 the next lesson. And in case I forget, remind me. Sawa?
Safi.
Okay. Kuna swali lingine? Nathan, you have any question?
Nilikuwa tu nimefanya my mistake pole.
Sawa. See you next time and have a good. Oh, Kelvin, I can see your hand.
Mwalimu, nilikuwa naomba in the next lesson hiyo trigonometry 2 hiyo number 2 hiyo 8 marks. Kuna penye nimepotea kidogo, lakini nitajaribu next time ta clarify kiasi.
Hata next time I can still repeat kama utakuwa umeelewa bado.
Yeah.
Sawa, no problem.
Okay, thank you.
Okay. Ending the class. Maybe the last question that, yes, Kelvin, bado kuna swali? Ama uko sawa?
No.
Okay. Okay. See you on Monday then, and please don't forget to do the assignments. They are very, very important, and each question has its own concepts. Ni vizuri ujaribu maswali yote. Tuone vile tunasaidiana vizuri. So you have a nice weekend, and let me meet you on Monday.